This video should help you learn to work with dilations on a coordinate plane. So we're going to look at a couple, and specifically we're focusing on two things. You need to be able to identify the scale factor, and you need to be able to identify the center of dilation. So all of them are given dilations. Let's do a quick introduction to dilations. When we have a dilation, it's given information that we have similar polygons. So you do know about ratios of corresponding sides. There's some notation that I'm going to briefly point out. When we use we use what we call prime notation. So if you take a look at A prime, B prime, C prime, that's indicating that it's the second coordinate. So that's the transformed image. We call it the image. And we call actually the first one that was transformed, in this case ABC, we call it the pre-image. Notice in the second one here, triangle DEF is the pre-image, and triangle D prime, E prime, F prime, the smaller one, is actually the image, the transformed one. So that's going to take into effect when we do our scale factor in terms of which way we're going, and I'll point that out in a second. So let's go ahead and start with our scale factor. And when we do the scale factor, you're thinking similar polygons, same as we did the rest of Chapter 7, and I want you to find the ratio of similarity between the two triangles is all we're really doing. So I'm taking a look at this, and I'm going to just count here. And as long as I'm horizontal or vertical on the graph, I can count. And I'm counting 1, 2, 3, 4, 5, 6 for A prime, B prime, and then 1, 2, 3, 4 for AB. So when I make my ratio, I'm going to do it in exactly that order. A prime, B prime over AB is in a ratio of 6 to 4, which reduces to 3/2, and that would be my scale factor. You could also write that as 1.5 if you prefer. So 1.5 would be an acceptable answer as well. Notice the order I did it in. You do want to make sure that you're doing it the new coordinates or the new length on top, the image versus the pre-image. Because if you do it the other way, we would have gotten a ratio of 2 to 3. These just would have been flipped. And that would be indicating that our image was getting smaller. Whenever we have a dilation, we can talk about it as an enlargement or reduction. And an enlargement would be getting bigger. We have to have a scale factor greater than 1, and 3/2 is definitely greater than 1 for it to be getting bigger, and likewise smaller than 1 for it to be getting smaller. You could go ahead and find a second pair of, or you could really find all the sides, all the ratios of corresponding sides. There's no real need to, because they should reduce to the same thing. We know the triangles are similar, and that's part of our definition of similarity. If you want to check your work, that's absolutely okay. So if I did that on this one, that would be me now doing the ratio of, let's go with different color here, B prime, C prime to BC. B prime, C prime to BC gives me, if I count that, 9 over 6, which is reducing to the same 3/2 that we just got a second ago. So part 2, that was part 1, find the scale factor. Part 2 is find the center of dilation. And in this case, we're looking for a coordinate point, an actual coordinate point. The way you're going to find this is you're going to take a ruler, would be easiest. I'm going to kind of estimate on here, but what we want to do is draw a line through each pair of coordinates, the original pre-image coordinate and its corresponding image coordinate. So that would be from B to B prime, but let's not just do that. Let's go ahead and extend that line. And like I said, if you have a ruler, that would be best, because you do want to be as accurate as possible and get a straight line. And then I'm going to go from C to C prime, and then I'm going to go from A to A prime and extend them. And those 3 lines, or if you have a different polygon, if you have a quadrilateral, it will be 4 of them, will intersect in one point. They're what we call concurrent lines. That's when we have 3 or more lines that intersect in the same point. We call them concurrent. New vocabulary word for you. And that point of concurrency is indeed the center. So this one is 0, 0. It doesn't have to be the origin. If you take a look at the second one, just to give you a different example, that would be me connecting D and D prime me connecting F and F prime, and then E and E prime. And again, ruler would be helpful, but it appears that we do have a point right there that would be the center of dilation. -4 and -1, 2, 3, 4, 5, I believe, for the Y value. Okay, so that's an example of how do we find the center of dilation. We went over how to find the scale factor. There's one other thing that I want to mention. 1 and 2 are okay. When you get to number 3, if we talk about finding the scale factor, actually let's just talk about 3 in general. A couple interesting things going on here. First one is that the center of dilation, unlike in 1 and 2, where it was outside of the triangles, and they were kind of going from one point, getting bigger in all directions. Same thing with this one. When you look at number 3, we definitely have an enlargement or reduction happening within the figure or around the figure. In this case, it is getting bigger around itself, which means that the center of dilation is going to be inside of the figure. So if you kind of picture what's going to happen here when I connect my corresponding vertices, we should already be able to, whoops, let's try that one again. And sometimes it doesn't want to actually erase what I did. Get rid of that. Okay, let's try again. Okay, so I'm estimating, but I think you can tell right here we do have a common point of intersection, and I obviously didn't do the fourth one. So center of dilation can be anywhere, but it will obviously look different depending on where it is. What I really wanted to talk about with number 3 before I end this video is how do I do a scale factor when I don't have any vertical or horizontal lines that I can count. Notice up here I completely ignored AC when we were on this one, AC and A prime, C prime, because they weren't things that I could count. And I didn't need to use them because I had 2 other pairs of sides that I could use, and I checked both of them. When I get to number 3, I don't have an option. I'm going to have to use distance formula to find lengths. But the good news is you don't have to find that many distances. You need 1 pair of corresponding sides. So pick a pair of corresponding sides and do your distance formula. I'm not going to take the time right now to do it. I'm just going to kind of set it up for you. That would be me getting the coordinates of J and I. I didn't give you the coordinates, so you're going to have to get the coordinates. And then you're going to figure out Ji equals radical, do the distance formula, x2 minus x1 squared plus y2 minus y1 squared. Simplify it, however you can simplify it. And then you're going to do J prime, I prime. So you need 2 more coordinates. Whoops. J prime and I prime. Radical and repeat, do the distance formula. And just to save a little time, I'm going to let you go ahead and do that. The simplified answer, just so you can check your work on this one, if you do those, and you didn't have to, I just randomly picked 2 lengths, but if you do those 2 lengths, you should be getting a radical 2 for Ji, and you should be getting a radical 32 for J prime, I prime. Recall that radical 32 can be simplified. That would be radical 16 times 2. 16 is a perfect square, so 16 comes out as a 4, and I'm getting 4 radical 2 for my simplified version of J prime, I prime. Now, when I talk about that as a scale factor, my scale factor I'm going to do, again, new over old, or image over pre-image. So I'm going to do J prime, I prime over Ji. So I'm going to have 4 radical 2 over radical 2. The radicals cancel because I have the same thing in the top and the bottom. So my scale factor is ultimately just 4, or 4 to 1. And that should make sense if you're looking at it. The image is 4 times as big as the pre-image. Okay? Hopefully that helps you. I'm doing a quick look to see if anything else looks crazy here. So just to recap, when you're doing the scale factor, you will need to use distances, but only distance formula, but only use that if you can't count vertical and horizontal lengths. And I'm going to leave the back side for you to try. Nothing too crazy happening there. Very similar to what we just went through.